my dear students. I hope you all are doing great. This is Seema Banjare, your mentor, your guide, and today we are going to start a new chapter. So this is chapter number 2 of class 9 CBSE, and the name of the chapter is Polynomials, right? So just for the sake of your convenience, I have divided this chapter into 3 parts, and this is part 1 of Polynomials, just because I don't want the length of the chapter to exceed, so that it becomes, boring for you to go through it, right? So this is part 1 of Polynomials. Before we actually start the chapter, let's see what all we will discuss in today's class. So the first thing that we will be discussing will be definitely the basics of polynomials, like what are polynomials and different types of polynomials. Then we will move on to discuss zeros of a polynomial, right? And roots of polynomial equation, right? So without wasting any further time, let's quickly get started. What do you think? Are algebraic expressions and polynomials same? I have seen many students using these two terms interchangeably, right? They think that polynomials are same as algebraic expression, though polynomials are algebraic expressions, but not every algebraic expression can be a polynomial. You get it? Let's understand it, right? So, algebraic expressions. So what are algebraic expressions? Algebraic expressions are made up of 3 terms: variable, constant, and operations, right? So these 3 things make an algebraic expression, right? Like variable, constant, and operations. Let's take an example. 5x square plus 3y. Here in this expression, you see x and y are variables, right? 5 and 3 are constant. And operations can be anything like addition, subtraction, multiplication, and division. But in this expression, we have 2 operations. One is addition and multiplication. Here you see 5x square. So in this term, multiplication is used. So algebraic expression is a combination of all these 3. Now you must be wondering that polynomials also have the same definition. Then what's the difference? So let's talk about polynomials now. Polynomials are actually a type of algebraic expressions, in which the power of variable needs to be a whole number or non-negative integer. Okay, I have used this word or, right? By this, what I mean, power of the variable should be a whole number. A whole number are 0, 1, 2, 3, 4, 5 and so on. Okay, you can either call them whole number or you can call them non-negative integer, right? Let's take an example. 3y cube plus z. Now here the variables are y and z, and the power of the variable is 3 in this case, and here the power of the variable is 1. Now the power of the variable is a whole number in this case. That's why this expression is a polynomial. Let's take another example. 7y to the power minus 2 plus z. What do you say about this expression? This expression, here you can see the power of the variable y is minus 2, which is a negative integer, right? Which is not a whole number. That's why this is not a polynomial. Okay, so polynomials are a type of algebraic expressions in which the power of a variable is a whole number or a non-negative integer, right? So if you want to visualize it, you can understand it like this. If you think that this huge bag is of algebraic expressions, right? Then polynomials make a small they occupy a small portion in this huge bag, right? Okay, polynomials, right? Where the power of the variable needs to be a whole number. That's why I said polynomial are algebraic expressions, but not every algebraic expression will be a polynomial. You get it? Right? So now move on to discuss different types of polynomials. Okay? So how many types of polynomials are there? It depends on what is the criteria to divide them. So on the basis of number of terms, okay, number of terms. How many terms a polynomial has, right? So on this basis, polynomials are categorized into monomial, binomial, trinomial and so on. Okay, so what does we mean by number of terms? Let's see it. Take this example 6xy plus 5. Now in an expression the terms are divided, separated by plus or minus sign. You keep this in mind that the terms are separated by either a plus sign or a minus sign. Here you see we are using this plus sign here, right? So these two terms are separated by this addition sign. So how many expressions do we have? We have how many terms do we have? We have two terms here, first term and second term, right? So how many terms this expression has? Two terms. Let's take another example. 5x plus 7 minus x, right? Or you can just take it as y. How many terms this expression has? Okay, again you recall what I said. In an expression, the terms will be separated either by a plus sign or a minus sign. So you just find out where all we have plus or minus sign. So we have one plus sign here and one minus sign here. So definitely these terms are different terms, right? So how many terms do we have in this case? We have three terms, 1, 2, 3. So on the basis of number of terms, polynomials are divided into monomial, okay, monomials, binomials, trinomials and so on. Now trinomials, right? M-I-A-L-S. Okay, so monomial means one. So if a polynomial has only one term, then it will be a monomial. For example, 5x, or take some more examples, 2y or 5. 5 is also a polynomial. We'll be discussing it later on, right? Okay, so 5x, 2y, 5, they are a polynomial, right? Okay, let's see why 5 is a polynomial, because you will say that there is no variable in 5. Then why it is a polynomial? Okay, if 5 doesn't have anything with it, let's say 5, if I write it like this, 5x to the power 0. So x to the power 0 is what? 1. Okay, you remember we have said that the power of the variable should be a whole number. It can either be 0, 1, 2, 3 and so on. So here if we take the power of x as 0, okay, x to the power 0 will make 1 and 5 into 1 will make it 5. So from here we can conclude that 5 is a polynomial. Now you understand why 5 is a polynomial. Okay, so these are examples of monomials because they only consist one term, right? Let's see what are binomials. I hope you are getting it. Okay, so binomials, it means it needs to have two terms, right? For example, 2x plus y. How many terms are there? 1, 2, two terms, right? Take some more example. 5x square plus y. Again and again I'm using this word 5 because it's coming to my mind. So that's why I'm using it. So 5x square plus y. How many terms do we have here? We have two terms here. That makes it binomial. Okay, by for 2. So it has two terms in it. Now trinomials. Any expression or any polynomial that has three terms. For example, 7y cube plus x minus 3. Okay, so it has three terms. So 1 term, 2 term and 3 terms. So these are, okay, so it has 3 terms, that's why it is a trinomial. Clear? So if there are 1 term, it will be a monomial, 2 terms, binomial, 3 terms, trinomial. So this way it keeps on going. But we haven't named, the further expressions, because, if there are 4 terms, a separate name for that, 5 terms, a separate name for that. So it would be, too tedious, and we have just given, these 3 names just because these are the frequently used expressions, right? So that's why we have given name to only these 3 expressions, wherein the terms are, number of terms are 1, 2 or 3, and for the further later on we just call them polynomials. So what are polynomials? Polynomials, any expression that has 1 or more than 1 term, that will be a polynomial. Okay, right. Now let's see types of polynomials on the basis of degree, right? On the basis of degree. Okay, on the basis of degree, right? So to understand this, we need to know what degree of a polynomial is. Okay, so degree is the highest power of a variable in an expression. Let's say this example, 4x cubed plus 7y. Now degree of a polynomial means the highest power of a variable in an expression. Now here you see there are 2 variables, one is x and one is y. The power of x is 3 and power of y is, no power means 1. So the power of y is 1. So what is the highest power? Obviously 3. Okay, so what degree says? Degree is the highest power of variable in an expression. So which means 3 is the degree of this expression. Clear? Now if I ask you what will be the degree of 8z square plus z, right? So degree, power is 2, power is 1, highest power 2, it means the degree is 2, right? Let's take one more example. 7y plus 2. Here y is a variable and the power of y is 1. Okay, so 2 is a constant, right? So constant means the power of the variable, whatever the variable is, power of the variable would be 0, right? So here the power of the variable is 1 and that's the highest power. So here the degree is 1. Clear? So on this basis, what will be the degree of the polynomial? On this basis, polynomials are divided into linear polynomial, quadratic polynomial and cubic polynomial. So let's discuss them. Linear polynomial, quadratic polynomial and cubic polynomial. So if degree is 1, so the polynomial would be linear. If degree is 2, the type of polynomial would be a quadratic. And if 3, cubic, right? So the degree of the polynomial would be a cubic polynomial. So let's take some example. X plus 1. Highest power is 1, degree is 1. So that is a linear polynomial. Quadratic polynomial, x square plus 2y. This is a quadratic polynomial because the degree is 2. Now cubic polynomial, y cube plus x square. Here in this expression, what is the highest power? Highest power is 3. It means the degree is 3. Okay, and the degree is 3 means it is a cubic polynomial. Clear? Okay, so if the degree is 4, it would be a biquadratic polynomial. So this way we can keep naming them, but we don't, because these are the frequently used polynomials. That's why we have given them some name, right? Okay, so the types of polynomials is done, right? So it's done. Now we'll move further to see the value of a polynomial at a certain point. Okay, so let's take a polynomial. How we denote polynomials in mathematics? So this, okay, while going through your book, you will find this expression px written very often. What does it mean? It means that polynomial in variable x. If I write it as py, it means a polynomial in which the variable is y. If I write it as pz, it means a polynomial in which the variable is z. Okay, so now we will be discussing the value of a polynomial at a certain point. For that we need to take an example. So let's take an example. Let's take the expression, the polynomial be 3x square plus 2. Now this is a polynomial, right? And px, the polynomial is 3x square plus 2. Now if I ask you find the value of this polynomial at x equal to 1, okay, so how you will find out? Okay, at x equal to 1, you need to keep in place of x, wherever there is x, put the value of x as 1. So let's do it. So what I'm asking you to do, I'm asking you to find out the value of this polynomial at 1. It means what I'm asking you to find out p1. Okay, so you need to replace x with 1 in the expression. You need to replace x with 1 in the whole expression. So it would be 3 1 square plus 2. Okay, 3 1 square plus 2 and 3 1 square is 1. So it would be 3 plus 2 and 3 plus 2 is 5. So P1 will be 5. Okay, so the value of this polynomial at 1 is 5. You get it? Okay, let's take one more example. You know, more and more examples make the concept clear, right? So we are just taking one more example and then we will move further to the next concept. Okay, let's take one polynomial py. It means the polynomial is in the terms of y. So 5y minus 3. Now this is the polynomial. You have to find out the value of this polynomial at y is equal to 1 upon 5. So you have to find out the value of this polynomial when y is 1 upon 5. It means what I am asking you to find out, I'm asking you to find out p1 upon 5. Okay, so you need to replace y with 1 upon 5 in the whole expression. So we just have y at one place. It means we will be writing it as, in place of y, we need to write 1 upon 5 minus 3. 5 will get cancelled out. It will be 1 left. Yeah, this cancels out, right? So 1 is left, minus 3, and 1 minus 3 is what? Minus 2. So p 1 upon 5. So the value of the polynomial at 1 upon 5 is minus 2. Clear? Okay. Now let's move on to discuss zeros of a polynomial. Clear? I hope the pace is really fine. Okay. If not, you can comment me down. I'll slow or I'll increase the pace on the basis of your suggestions, right? Okay. So now we will move on to discuss zeros of a polynomial. Now, what does zeros means? As the name, this name suggests zeros, the literal meaning of this word, zeros. Okay, what does it mean? Zeros means that value that makes the polynomial 0. You know, that value of the variable that reduces the polynomial into a 0 is zeros, are known as zeros of that polynomial. For example, let's take a linear polynomial. You get it? What linear polynomial is? Linear polynomial, do you recall? Linear polynomial means where the power of the variable is 1 and degree is 1, right? So that kind of polynomial would be a linear polynomial. So let's take an example. So we are taking a polynomial x plus 5, right? Okay, so zeros of this polynomial would be that value of x at which this polynomial would reduce to 0, right? Now let's take one example. If you replace x with minus 5, okay? If the value of x would be minus 5, what will happen? Minus 5 plus 5, this will cancel out and it will become 0, right? So minus 5, the value of x minus 5, that has made this whole expression a big 0. right? Anything that makes the expression 0 is the 0 of the polynomial, and in this case the 0 of the polynomial is -5 because that value reduced this whole expression into a 0. Clear? Okay, let's take one more example. Let's take as x minus 3. What do you think? What is the 0 here? If you place 3 in place of x, right, at 3, this expression will reduce to 0. Let's see, x in place of x we are keeping 3. So 3 minus 3 would be a 0, cancels out, right? So it becomes 0. So 3 has reduced this expression to a 0. That's why the 0 of this expression is 3. So 3 is the 0 of this expression. Clear? Okay. Now these were simple expressions, right? And we could easily find out the 0 of the polynomial by just looking at the expression. We could easily make out that what would be its 0. If I ask you to find out the 0 of this polynomial, right, 5x plus 8, it's a bit typical, it's not that easy, right? So how we are going to find out 0 of any polynomial? For that, we just need to equate this expression to 0, right? So we will equate this expression to a 0. Okay, we are assuming that it has reduced to a 0. Just equate it to 0 in simple terms, and then just find out, solve this expression to find out the value of x. So 8 will go to the right hand side, it will become -8, x is equal to -8, and in anything with the x and multiplication will go down. So it will come here, and the value of x is -8 upon 5, right? So at this value, if you keep it here, -8 upon 5, so -8 upon 5 will get cancelled out, and we will be left with -8 plus 8, that will be 0, right? So this value of x will make this expression a 0. That's why the 0 of this polynomial is -8 upon 5. Let's take one more example. Okay, so we have so far we have found the zeros of linear polynomials. What if the case is like this? Okay, so this is a quadratic polynomial, and you need to find out the 0 of this polynomial. Again, the step would be the same. First thing that we would do is we will equate this expression to a 0, right? Just equate px to a 0, which means x square minus 4 is equal to 0, and x square minus 4 is equal to 0 means is equal to -4 will go to the right side, and x square is equal to 4, it means x is equal to √4, and √4, okay, √4 would be either +2 or -2. You know why there are two answers, +2 and -2? Because +2 on squaring gives you 4, -2 also on squaring gives you 4. That's why √4 will be either +2 or -2. So the zeros of this polynomials are +2 or -2, right? Okay, so now we will discuss what are roots of a polynomial equation. Like you must have seen this word used in your books very often, and you have seen your teachers also using this word interchangeably many a times, because we subconsciously use either 0 or roots, but there is a slight difference between these two. Okay, so let's see a root of a polynomial equation. What I'm saying, zeros of a polynomial and root of a polynomial equation. So that is the difference. Polynomial equation. Okay, equation, what comes means we have to say root. If we are just saying polynomial, it means we are talking about zeros, right? For example, if I ask you to find out the 0 of this expression, so what is this? This is an equation because equal to sign is coming there. So this is a polynomial equation, and if I just write it as x plus 2, so what is this? This is a polynomial. There is no equal to sign. This is just a polynomial, okay? But here we are just considering this. So this is a polynomial equation. So when we are finding out, that value of x where the whole equation will become 0. Actually it's equal to 0, right? So root of this equation means that value of x which satisfies this equation will be its root. You get the point? That value of x which satisfies this equation would be its root. Okay, if I ask you to find out the root of x plus 5x is equal to 2. So you need to find out that value of x which satisfies this equation. You're getting the point, right? You are understanding the difference here. That value of x which makes the expression 0, and here what we are saying, that value of the variable or x or y, any variable that satisfies the equation, that justifies the equation, will be the root of that polynomial equation. That's the slightest difference between these two, but we generally use these two words interchangeably without realizing that there is a difference between these two terms, roots and zeros. So that's the difference between these two, the basic difference between these two words. So now let's solve this equation. X plus 5x is 6x is equal to 2, right? And x will be 2 upon 6, and 2 upon 6 is what? 1 upon 3. So this is the 1 upon 3 is the root of this polynomial equation. Simple. Okay. With this we have come to an end of this video. I want you all to please like, share and subscribe to the channel. We'll see you in the next video. Till then, bye bye. Take care.